Good evening, everybody, and welcome to our Spring Newman Lecture, The Catholic Faith and Evolution, with Dr. Dan Kuebler. This is the third installment of our lecture series on faith and reason. Whether you are a student, faculty member, or a member of the larger community, we want to thank you for attending. My name is Isaiah Rodriguez, and beside me is Charlotte Simpson. We work with the Newman Center at Oregon State University, a Catholic campus ministry, to put on events like this to the greater OSU community.
As Isaiah said, my name is Charlotte, and I graduated last spring from American University in Washington, D.C., and moved to Oregon just last August to work here at the Newman Center. And I've been attending Newman lectures for the past 4 years, both online webinars streamed from Oregon State University and in person at American University. And through this series, I've been exposed to intellectual formation that has expanded my worldview and deepened my understanding of Christianity, the church, and my own faith.
We would especially like to welcome anyone here who it is their first Newman lecture. Dr. Kuebler is one of a number of great speakers who have come to Oregon State for discussions on urgent and thought-provoking topics surrounding matters of philosophy, social issues, and religious belief. I anticipate that through this lecture and participant questions, together we can come to a deeper understanding of the nature of humanity through a scientific lens.
I'd just like to take a moment to explain how the night is going to go. So Dr. Kuebler will speak for about 45 minutes, and following the presentation there will be time for questions. So Isaiah and I will be at the front of the aisles, and you can voice call from Sam Luckman.
Incoming voice call from Sam Luckman. Voice call from Sam Luckman.
Oh, nice.
Sorry, I was getting a phone call. So Isaiah and I will be at the front of the aisles, and after the talk we can form 2 lines on either side. And we welcome all questions. However, for the sake of time, and so that we can get to as many questions as possible, we request that you ask only one question and remain succinct and to the point. And now the director of the Newman Center, Father John, will say a few words.
Thank you, Charlotte. So on behalf of the Newman Center at Oregon State University, welcome to the spring edition of the Newman Lectures. The Newman Lectures aim to foster an important discussion between faith and reason, faith and science, faith and the university. John Henry Newman, after whom these lectures are named, once wrote that a science is not mere knowledge. It is knowledge which has undergone a process of intellectual digestion. It is the grasp of many things brought together in one, and hence is its power. For, properly speaking, it is science that is power, not knowledge. The Catholic Church has always been deeply invested in the progress of science and has confidence in the dialogue and harmony between faith and science. Being able to integrate the knowledge of nature into a rich worldview is what makes it truly a science, and is one of the benefits of this dialogue. We trust that this lecture series, and today's lecture in particular, regarding the Catholic faith and evolution, will help us to see the richness of this dialogue. Therefore, allow me to introduce our speaker for this evening. Dr. Kuebler is a professor of biology at Franciscan University in Steubenville, Ohio, where he teaches courses on evolution, cell physiology, and science and faith. He is the co-host of the Purposeful Lab Podcast on EWTN, a podcast that examines the order and purpose inherent in the world around us. Dr. Kuebler is the co-author of The Evolution Controversy, a survey of competing theories, and another forthcoming book on evolution and Catholicism. Dr. Kuebler was telling me about it right now. He is Vice President of the Society of Catholic Scientists and is on the board of the Spitzer-Magis Center. He has been married to his wife Nellie for 26 years and has 6 kids and resides in Steubenville, Ohio. So welcome, Dr. Kuebler.
Well, thank you, Father John. Thank you for that introduction. It's a pleasure to be here. This is my first time in Oregon, and it's beautiful weather outside. So, I almost made it to Oregon when I was in grad school at Berkeley. My wife and I got about 10 miles from the border, and she started to feel sick, so we turned around and went back. So we regretted that. We figured out we'll come back another time, and we never have. So it's a pleasure to be here. So I'm going to talk tonight about evolution and the Catholic faith. And really what I want to focus on is a question that people often ask, you often see written about, what's the meaning of evolution, right? Chance or purpose. And so if you read popular books about evolution, you'll find people try to extract meaning from evolution and the evolutionary process, and all over the map. So the biologist Douglas Fukuyama, for example, he says, some shrink from the conclusion that the human species was not designed, has no purpose, and is the product of mere mechanical mechanisms, but this seems to be the message of evolution, right? So you have that end. On the other end, the biologist, Father Nicanor Austriaca, says the message of evolution is that to demonstrate God's grandeur, because he can create more species through an evolutionary timescale than if you just have species that exist over the course of 6,000 years, for example. I think the most interesting is the biologist J.B.S. Haldane, who said the meaning of evolution shows that God has an inordinate fondness for beetles. Over 350,000 different species of beetles and counting. So you can see people can come up with a lot of different sort of answers to the question of what's the meaning and purpose of evolution. Why do we live in a universe that's evolved, both cosmically and biologically, right? And it's important to recognize, I mean, that's a normal human question to ask the meaning and purpose of something, but it's not a scientific question, right? That said, it does depend upon the science. So understanding the scientific process of what happened during evolution can allow us to inform that question, but it's not a scientific question per se. And Pope Benedict makes this point. I love his quote. He says, of course, the question remains open whether evolution as a whole has a meaning or doesn't have a meaning. But it cannot be decided within the theory of evolution itself. For that theory, this is a methodologically foreign question. Right? So understanding purpose and meaning is not something the modern scientific process does. It explains how things work. The greater meaning and purpose of things goes beyond that. Right? So it's something that biology is a dialogue with it, but it goes beyond that. But at the same time, it's a very meaningful question. He said for a live human being, it's the fundamental question of the whole thing. For humans, we want to know the purpose, the meaning, or is there a purpose or meaning to this, right? And so that's what I want to sort of get at tonight, to talk a little bit about that. Okay. Now, one of the sort of, I think, common sort of questions people have about evolution when I teach a lot of undergraduate non-science majors, when they ask about evolution, how they can reconcile that with their Christian faith, or Catholic faith. They struggle with the idea of this sort of chanciness of evolution is one aspect, and then the fact that evolution is littered with death and extinction, right? And they say, how does that jive with an all-loving God, for example, right? So the evolutionary process seems to be, in a sense, an inherently risky enterprise. Right? So there's an example up here of this sort of chanciness of evolution. Here's a picture of an asteroid hitting the Earth, and so 65 million years ago. The theory is that an asteroid led to the major extinction event at the KT boundary, at which dinosaurs go extinct, and then mammals are able to diversify and rise to prominence as the dominant sort of predators on the landscape. And so the argument would be, well, if that asteroid doesn't hit the Earth 65 million years ago, animals would have never arose, humans would never be here. Therefore, humans are not, willed and loved by God. They're just a chance outcome here in the evolutionary process, right? So that's one thing I think often people struggle with. And the second has to do with sort of the death and destruction that you see in evolution. And Tennyson summed this up best, I think, in his in memoriam poem. He says, 1,000 types are gone, I care for nothing, all shall go. Speaking of sort of extinction of different types and species. And then he says, who trusted God was love indeed, and love creation's final law, though nature red in tooth and claw with ravine shrieked against his creed. He says, looking at all the death and destruction in the evolutionary process or in the world, seems to, counter the idea that there's a loving providential God. So maybe there's no meaning, it's just sort of chance and death, and that's that's the end of the story. Well, I think, I'm not denying that there's sort of chance and death and destruction in the evolutionary process. But if you're going to try to understand the meaning of something, it's good to understand, you want to go beyond, make sure you have the full scope of everything, right? So what is, the evolutionary process? Is it just chance and death and destruction, or is there more to it? Is there a lot woven in there? So just like if you want to understand a book, you read the cliff notes, you're not fully going to understand it, right? You want to actually dive into the book and get as much details as you can. Because I think it's problematic if you just look and pick a few pieces and then say, okay, that's the meaning of evolution because I saw this in it, I saw death and destruction, it's just death and destruction. It's kind of similar to people when they pull one quote from scripture and try to build the whole meaning out of it rather than seeing the whole, right? So there's something about looking at the whole to be able to understand and to contemplate the meaning of the evolutionary process. Right? And so what I want to talk about is the sort of the order that is there in evolution, right? So often when people think or talk about evolution, it's sort of the chance elements of evolution. I'm not denying there are chance elements, there certainly are, but there's an underlying order that I think is more fundamental to the evolutionary process, right? And I'm going to sort of make some of the argument. One, that order is a gift to evolution. It's something that evolution doesn't produce, it's given to it. And that is absolutely essential for the evolutionary process to work. And second, that order also helps dictate and direct evolution in certain directions, right? So it's just sort of a both and. You see the other side of that chance aspect, right? There's an order that it works with. And then the second is that death and destruction is not the only thing. There's that death and destruction is actually life-giving in a sense, right? It leads to birth, rebirth, and opportunities in the evolutionary process. So it goes hand in hand with the emergence of novelty and life-giving production. Right? Now, to start this exploration, I want to spend a little bit of time talking about chance and evolution, because I often get students that will have some type of argument like this that they're struggling with. They say, and I've already sort of alluded to this, the idea that evolution is influenced by numerous chance events, environmental perturbations, where you have a chance event that occurs that sets evolution off in a different direction, for example, right? So the idea is if there are these chance events that occur, then man is not the product of a loving creator, just a chance, we're just a lucky lottery winners of some chance event. So how do you really engage with that argument, okay? So the first thing I always want to talk about, and we're going to talk about sort of how the Catholic Church engages with chance and how it integrates chance and purpose from a philosophical perspective, because I think that's important to lay out on the table first. But then we're going to talk about the order and that you find in the evolutionary process that I think is important to really fully understand how evolution is dependent upon and how it actually operates. So our existence is riddled through with chance events, right? So it's interesting, I also see students that struggle with the idea of chance in evolution, but our everyday life is full of chance events. So me meeting my wife was certainly a chance event. She just happened to move in to an apartment that my friend lived in. Had she decided to move into a different apartment, I would have never met her. So our encounter was a chance event, right? But I also think that it was providential at the same time. So in our everyday life, there's got to be a way of integrating chance and providence from a Catholic perspective, from a Christian perspective, irrespective of evolution. So evolution doesn't give any new difficulties that we have to encounter with trying to integrate chance and purpose. It's just something that is there inherent in all aspects of our existence. Right? And so from a Catholic perspective, this is something the church has talked about and has dealt with for millennia. So you can see up here, the way the church deals with this is looking at primary and secondary causation. The idea that God being the primary cause of everything, this is something that Aquinas talks about, allows everything to exist. So often we think of it as God as one cause competing with us. So there's God here, either God did it, or I did it, or chance did it. Rather, God is the primary cause of all existence. Anything that happens, and anything that happens in the evolutionary process, only does so because God gives existence to that, right? So God is the primary cause of existence, allows everything that's contingent, and all of us are contingent beings, to exist, right? And so anything that we can explain via evolutionary processes doesn't exclude God. So the evolutionary process, asteroids only do what they do, dogs only do what they do because God allows them, gives them existence, right? As sort of the first cause, right? And so Aquinas talks about this. He says, the effect of divine providence is not only that things should happen somehow, but they should happen either by necessity or contingency. That's his term for chance, right? And therefore, whatever divine providence ordains to happen infallibly, and of necessity happens infallibly by necessity. And that happens from contingency, which divine providence deems to happen from contingency. So nothing that exists happens outside of God's providence. The other thing to keep in mind with this as well is that when we talk about chance, from the perspective of Christian God, chance doesn't really make any sense, right? So even from a human perspective, chance is something that is dependent upon our knowledge of the situation, right? So, for example, my 22-year-old son, he comes home, he hasn't met a good Catholic woman to marry, so my friend down the street has a 22-year-old daughter. She's home too, so I tell him, hey, why don't you go to the grocery store at 5 o'clock and buy a loaf of bread, and he tells his daughter they meet in the grocery aisle buying a loaf of bread. From their perspective, that's a chance event, right? There's just a chance encounter. From my perspective and my friend's perspective, it clearly wasn't, right? And again, that you can see that having knowledge, it makes it effective whether it's a chance event or not. And from God's perspective, God, Christian God, being outside of time, chance doesn't really make any sense, right? So chance is sort of a human construct. It's the way we see in the order of time. When God, who knows all things, when you're outside of time, you know all things at all times, it doesn't even make sense. So there is the idea that, there's chance events in evolution does no way, from a philosophical perspective, undermine the idea of providence. Okay? So with that background, though, I do want to talk then about sort of the order that you have in evolution and how I think that the order is primary, and even though there's these chance events are secondary, right? So chance certainly plays a role in the evolutionary process, but you see it's secondary to the underlying order in creation. And there's two arguments I want to make. One is that this order is absolutely essential for evolution to occur at all, and it's primary, right? And it's not something evolutionary builds, it's a gift to evolution, one. And the second is that this order actually sort of directs evolution towards certain solutions, okay? And so it sort of dictates, to some extent, what evolutionary outcomes can be, right? So it sets the parameters of what possibly can be in an evolutionary process, okay? So the first part of that, I ask the question, why does evolution work at all? Right? So why is biological evolution even possible? Right? So for biological evolution to be possible, right, you have to have stable, relatively complex living entities, right? If you don't have those, you're not going to have an evolutionary process, right? So you see a picture of me over there on, I don't know if you're right or left. That's from like 20 years ago, right? And you can see that I'm relatively stable physically, right? At least, right? I have a big nose then, I still have a big nose, very narrow eyes. So I haven't, my features aren't, randomly changing from day to day. I'm relatively stable. I'm an object of natural selection. Selection can operate on me because I have certain features. So if there's a virus that kills everybody with a big nose, I'm going to be gone, right? It's get small the next day. So there's selection can operate because it's a stable, complex entity, right? And they ask you, why do we occupy a universe that allows for such stable, complex entities to exist? Well, as biologists, I can maybe, let's explain that in the biochemistry. Well, because the proteins and lipids that make up are relatively stable. So the proteins that make me up, yeah, they can misfold and so forth, but they don't spontaneously turn into lipids or to water. They're relatively stable, right? And so why are they stable, right? Well, they're stable because we go to the chemistry, because we have roughly 94 relatively naturally occurring elements that are stable. So why do we only have 94, right? And why are they stable? Like a carbon atom is a carbon atom is a carbon. It's extremely, it takes a lot of energy to change it into something else, right? So why are there only 92 or 94 naturally occurring elements, and why are a few of them really, really abundant, right? Well, that can then be explained in the physics, right? If you go down to the level of physics and the strong nuclear force and the weak nuclear force and so forth, the size of the electron, that dictates what elements can exist, right? So you can see, as we're trying to understand why is there order and structure in biology, you can keep going down, but sooner or later you get down to the foundational level in the subatomic physics, where you can describe the order, right? But you can't explain it in a lower level of science, right? So the order that we see at the low level, sort of the subatomic physics, that order is absolutely essential to have these elements, right? Which is essential to have proteins, which is essential to have complex organisms. And that order is not something that evolves, right? That order is the order that the universe has, right? And if that order is altered, then you get a different set of elements, or you get one element, right? So if you change some of these forces, change the strong nuclear force or the weak nuclear force enough, you only get a universe that just has hydrogen, and then you don't have this possibility, right? So the idea is that there's a huge amount of order that's absolutely essential for evolution to work at all, to even get off the ground, right? To have elements, and to have compounds, and to have molecules that actually can produce, and eventually living organisms, right? And so, our universe has a specific physical and chemical structure. That's in a sense a gift, right? So with that chemical structure, it's a type that can allow evolution to work, but it also is going to affect, this is the second argument, the solutions that evolution will find, right? And so the physics and chemistry dictate a lot of what is possible and what can and is most likely to evolve. Right? So one way of sort of getting at this question of how does the underlying order in physics and chemistry affect the evolutionary process and direct it is to ask this sort of thought question that is, many evolutionary biologists have talked about, pose this question and try to answer it, right? So the idea is, what would happen if you reran the evolutionary process again? So if we could go back 4 billion years and rerun evolution on the Earth, right? Or if we had 50 Earths, then we could run it 50 times, right? What would you get? Would you get a totally new set of organisms? Everything would be totally different. Or would you get relatively similar? You're not going to get identical, right? Because there's a lot of chance of that. But would you get something that looked very similar, right? So there's sort of two extremes. It's either just totally contingent. If you ran it again 50 times, you're going to get 50 different, totally different things. Or if you reran it 50 times, you would get relatively similar, be highly convergent, right? Now, obviously, you can't do that experiment, right? So how do you get at that answer? Is there something about the order in the physics and chemistry that sort of dictates that you would get similar things over and over again? Well, one way of getting that is just to look at how evolutionary structures have evolved over time, and do you see a huge amount of convergence, right? Is the evolutionary process highly convergent, or is it not, right? And if you look at the evolutionary process, turns out that it does seem to be very, very convergent, right? And that you see similar structures, similar behaviors, similar process evolving multiple times, right? One of the most classic example is the camera-like eye that you and I have, that vertebrate camera-like eye with the lens in the front that can focus light on the retina in the back. And that's an eye that's evolved probably 6 or 7 different times in the evolutionary process. There's 2 up here, one in the cephalopods you can see there, and then one in the vertebrates. But you see it in sort of insects have it, even sort of jellyfish have a sort of a camera-like eye as well. So this is a structure that's evolved multiple times. I mean, there's something about this structure, the underlying physics and chemistry, the nature of light, that this structure would evolve multiple times, right? This book here by Simon Conway-Morris, this is one of my favorite books on evolution. Simon Conway-Morris, he's a paleontologist, but it's called Life Solutions and Ethical Humans in the Lonely Universe. And in this book, he lays out sort of the ubiquitous nature of convergence in the evolutionary process, right? And he argues that there is no real behavior or structure that has only really evolved once. You see, these forms evolve multiple times, right? You think of the form of, the fusiform form of fish, right? Moving through a viscous liquid of water. That form has evolved multiple times, right, in mammals and in fish, right? So there's certain things about the physics that mean that if you're going to be efficient in moving in water, you're going to have this form evolve multiple times, right? And he goes through example after example of this, right? Now, I want to give one example of this, because I think it's probably the most robust example of convergence that exists, okay? Is the idea that the underlying chemistry and physics sort of drives certain solutions. If you reran evolution again, you would get similar solutions because of the underlying chemistry and physics. Right? And I apologize to those who don't like biochemistry or protein chemistry, but it's by far, I think, the most robust example. So you see just behind me a cartoon of a protein. Proteins are made of amino acids, right? And amino acids, there's about 20 that are biologically relevant. Infinite number you can make, but there's 20 that are biologically relevant. And each one up here is like a different color, right? So if you had a protein that's 100 amino acids long, right? And most biological proteins are bigger than that. But if they're 100 amino acids long, the number of possible proteins you could have is 20 to the 100th power, and it's a staggering large number, right? So if you reran evolution again, what's the likelihood you're going to get the same sequence, same amino acids? It's 0, right? You're not going to get the same amino acid sequence, right? So it seems like if you reran evolution again, you get a totally different set of proteins, okay? But protein structure tends to be very, very convergent, right? So if you take amino acids, right, string them together, and you put them into an aqueous solution, right? They fold into predominantly 2 secondary structures. There's a couple minor variants, but if they fold, sometimes they don't, they just clump together, but if they fold into only 2 secondary structures, right? These alpha helices on my right and the beta sheets on the left. And why do they fold into those, right? They fold into those because that is what the chemistry dictates. They try to get their backbone away from water. So there's this hydrophobic, hydrophilic interactions. And so the backbone of all amino acids is the same. So they will fold. If you string amino acids together and put them into water, this is what the chemistry dictates. They're going to fold into alpha helices and beta sheets. So if evolution were to run again and proteins form, right, which would be highly likely given the abundance of amino acids you find abiologically throughout the universe. You see them in, on most asteroids and meteors that we recover. There's amino acids on them. You see those in, in planet-forming disks, right? So if you string amino acids together, they're going to fold into alpha helices and beta sheets. Why? Because that's what the chemistry dictates. And when you fold them into alpha helices and beta sheets, there's only a limited number of ways, it seems, that they can then fold into, there we go, higher structures, right? So you see these diagrams here where the alpha helices are these blue helices and the beta sheets are these pink arrows there, right? Once you have a protein, you based on the relationship between the alpha helix and the beta sheets, they could fold into these different protein folds. And it turns out, it seems to be that there's only a limited number of these three-dimensional folds. Right? There's about 1,000 of them. And again, it depends exactly how you classify them. Right? And so it seems that there's only a limited number of ways to fold alpha helices and beta sheets together to get these three-dimensional structures. So you start with basically an infinite number of sequences, and it funnels down, converges down into around about 1,000 different protein folds. And though if you reran evolution again, I would argue, you would probably get very, very similar protein folds, which means you would probably get very similar sort of molecular reactions going on, and life would be very, very similar to what we see around us now. So you see this high convergence, that order is dictating to some extent what would happen. Yeah, it's actually been, so normally when somebody crystallizes a protein and figures out its structure, they put it into the protein database. And I think it's been at least now over 20 years since a new structure has been found. So anytime somebody finds a novel protein, they crystallize it, figure its structure, oh, it's the same as the structure we already have in the database. So it seems like there's only a limited number of three-dimensional structures that are biologically useful. Right? So at this point, what I would argue is that we live in a highly ordered universe as described by modern physics. Right? So the subatomic level is very, very ordered. And that order is essential for evolution to work. Without it, you don't get stable elements, you don't get stable molecules, you're not going to get complex organisms. Right? But that order also influences the outcome of the evolutionary process. So this order is absolutely essential, right? And I think what the chance processes do is sort of uncovers the possibilities that lie latent in this order, right? Now, the timing of when they get uncovered and the sort of nature of them is going to vary, but you're limited based on the underlying order, right? What evolution is going to be able to uncover. Like the physics and the chemistry sort of dictate that. You're not going to get, for physical reasons, flying elephants. It's just physically not going to be possible to get something that large to be able to generate enough liquid biological material, right? Now, the other thing about the evolutionary process that is interesting is that it seems to, as a whole, if you look at the grand scale and step back and look at the whole sweep of evolution, and you can say this both cosmically, as you look at the origin of elements in stars and first and second generation stars, but also biologically, there seems to be a direction or progression in evolution over time, all right? And this is at the global scale. At least if we look back at what's happened on our planet, right, what we see is an increase in complexity and diversity in ways of making a living over the grand scale of 4 billion years of the evolutionary process. Okay? And this increase has been driven largely by sort of cooperation between cells. Right? So if you think of the prokaryote cells emerging into eukaryotic cells, it's via cooperation of two prokaryotic cells that starts to give rise to the more complex eukaryotic cells, right? When we talk about multicellular organisms, that's cooperation between individual cells that form these multicellular organisms, right? And then it's more diverse cooperation that allows for things like nervous systems and so forth, right? And so it seems to be that there is a direction, right? And Theodore Dobzhansky, one of the godfathers of the modern evolutionary synthesis, this is how he says, viewing evolution of the living world as a whole, from the hypothetical primeval self-reproducing substance to higher plants, animals, and man, one cannot avoid the recognition that progress or advancement or rise or ennoblement has occurred during this process. seems to be moving towards something, right? This process. Now, that doesn't mean there is something guiding evolution in this spooky sense, or there's some vital force inside evolution. But looking at the process, there does seem to be an increase in behavioral and a cellular complexity and ecological complexity over time. Right? Now, what this doesn't mean is that evolution is always moving towards something more complex. I'm talking about it's a grand scheme. So if you look at, zoom in at a local level, right, you see organisms that become less complex. They lose eyes, they lose limbs, right? You see even in hominid evolution, you see species that go towards smaller brain size, right, during the last 7 million years, right? So it's not as if everything is, there's this inherent always moving towards complexity, but it seems that as you have the evolution process move, organisms are storing information, ways of making a living in their genomes, right? And those are stored and then built upon, so you start to get the increases in diversity and complexity over time as a whole, right? Even though there are, it's not something that's ubiquitous, that it always occurs in every single lineage, right? And this is something even the agnostic or atheist, Wilson, points out. He said many reversals have occurred along the way. So he's talking about the species that lose eyes and so forth, that have non-functional eyes from eyes. But the overall average across the history of life has moved from the simple and few to the more complex and numerous. During the past billion years, animals as a whole evolved upward in body size, feeding and defensive techniques, brain and behavioral complexity, social organization, and precision of environmental control. More precisely, the overall average of these traits and their upper extremes went up, right? So there does seem to be a movement, a progression in the evolutionary process that has occurred. Right? So that's sort of the other side of the chance. So rather than just seeing evolution just as a chance and random, right, in a sense, there does seem to be an underlying order that's essential for it that directs it in certain directions, and there does seem to be over time a progression in the evolutionary process in sort of a general sense. Right? Now, the other thing that I mentioned at the beginning that often people focus on in the evolutionary process and see difficult to reconcile with a Christian thing is this idea of death and destruction, right? The death and the extinction. But that death and destruction, as I said, is always counterbalanced, at least on the 4 billion years of evolutionary history on our planet, has always been counterbalanced with rebirth and renewal, right? And often, so the evolutionary extinction is laying the groundwork for more complexity to come, right? And so, for example, if you look at the Devonian organisms, this is where the first sort of tetrapods, 4-limbed animals, start to emerge, right? And if you look at the extinction of some of these early tetrapods in the Devonian, leads to and gives rise to and sets the stage for more complex tetrapods in the Carboniferous, where you get actual, pentadactyl 5-digit 4-limbed creatures. So there's something about the death and extinction, which these transition or intermediary species are there, providing the opportunity for the evolution process to move towards more complexity and more forms, and that death of those and the extinction of those provides this opportunity for rebirth, right? All the major extinction events have given rise after that to a new flowering of diversity, just like we talked about at the beginning, the idea of the extinction of the large, the dinosaurs 65 million years ago led to a diversification of mammals. So you have this death that leads to more rebirth and life. You can see example after example of this if you look at the Ediacaran fauna, which and fossils that predate the Cambrian. The Cambrian is the time when you have a lot of basically most of the modern animal phyla appear. You think hard body parts, segmentation, an obvious sort of head, tail, axis, bilateral symmetry. But you see in the Ediacarans the remnants of that, so very simple bilateral, sequence, right? Very simple segmentation in some animals. They go extinct, but that allows for these, they lay the groundwork, which leads to a flowering of complexity, right? So this death and destruction is creative, is the point, that there's some life that comes out of this, and it's not the end of the story. Right? So this gets back to the question that I had at the beginning that Benedict was asking. It's like, what is the meaning of this whole thing? Okay, what's the meaning of it? So, I think if we're going to try to understand the meaning of evolution, right, we have to first get a best picture of it, right? It's not just chance and it's not just death and destruction, it's more than that. Right? And once you have that scientific perspective, I think, of what actually is going on or what actually is happening, then it puts you in a principle to really understand and to step back and sort of philosophically and theologically respect, what does it mean, right? What's the meaning of it, right? So this is, at this point, I'm going to sort of step back and theologically and philosophically reflect. I'm not talking as a scientist here. I'm not saying this is a scientific conclusion, but based on the science, how can we think about evolution, right? And one of the things that really sort of strikes me about evolution is that evolution has a lot of parallels, evolutionary history, with salvation history, right? So often we think evolutionary history, and students are like, oh, there's the salvation history, how God was acted in the Christian story, and then there's evolutionary, and maybe we can fit them together, but there's nothing, it's kind of messy, and they're clearly just, evolution's kind of weird, but maybe we can just sort of tack it on. But I think if the same God stands behind, and there's a long history in the Catholic tradition of the same God stands behind nature, stands behind the scripture, right? Then it wouldn't be surprising to see similarities between the two, okay? There's a lot more than what I have here, but I just want to point out three of them, the three of these synergies and similarities that I think that you see there in these two processes, right? The first is that both are a journey. They seem to be a destination towards something, right? Now, again, that is not a scientific conclusion, but if you look at the evolutionary process, it does seem there is this progression that occurs, right? And that certainly is the case in salvation history. It's a story of progression. They're getting towards Christ in salvation history. The second one, I think, is probably even more interesting, okay, is that they both display an openness to creaturely freedom. Right? So if you think of the evolutionary process, right, it is not a deterministic creation account. You see, oh, God puts this species on there, and He puts this species, and God's this dictatorial God using, controlling everything. But God gives His creation these inherent potentialities, right? The chemistry and the physics, the order that's there in creation, which allows creatures to do what they do and bring about, over time, a whole host of different species, right? And so the evolution process is bringing forth these, but it's bringing forth these because that's what God has allowed in the creation that He has produced. Okay? And this is a quote from theologian Matthew Ramage, who I really like this quote because I think it summarizes this distinction and the similarity between the way the freedom, creaturely freedom in evolutionary process with salvation history. He says, creation does not merely follow the pre-programmed instructions of a divine craftsman, nor does God tweak His story or score in the middle of its performance as envisioned by some Christians. On the contrary, evolutionary adaptations arise naturally from within the story of creation itself, according to the rules of its nature, instilled therein by its divine author. But why would this author allow his script to seemingly go off the rails at points? In brief, it is because God has bestowed on creatures the dignity of being real causes. Right? This primary and secondary causation I alluded to earlier. And their errors, our errors, are all known to God and allowed as part of His plan. Right? And you think about that in evolutionary, so these errors, these mutations, these chance changes, these environmental perturbations, they're all part of that plan. And it seems like, well, it could go off the rails, right? You could have a huge extinction and all species go extinct, but it doesn't. It eventually leads to the creature that God destines to know and love and serve Him, right? But you see the same thing sort of in salvation history as well, right? So like the sins of David and the sins of Solomon don't derail the story. So why would God allow these sinful people part of the salvation story? It could go off the rails, but it doesn't, because God works through all of these features. They don't derail his plan. Much the same way, I think, that you see in evolution, right? And then the third similarity that I want to highlight is this sort of this death and destruction, that out of it becomes rebirth, right? And not only rebirth, but it becomes a renewal that's even more impressive, right? And you see this throughout salvation history, right? You see this down here in the destruction of the temple in Jerusalem and before the Babylonian exile, right? It seems like, the salvation history's come to an end. The Israelites have been taken off in captivity. The temple's been destroyed, but this leads over time to the rebuilding of the temple, the second temple, which actually held a more central place in the life of the Jewish nation than the first. So you have this destruction and rebuilding that brings sort of new life. Same with like the early Christian martyrs and how the blood of the church leads to Christendom. And then most importantly is actually the essential event of Christianity, the death and the resurrection of Christ. If that's the central event of Christianity, why would not you see death and rebirth as a central part of the evolutionary process? So I think there's a natural sort of synergy there between the way we see God working through evolutionary history as we see God working in salvation history. And I think that you can see that the evolutionary history, through its twists and turns, that underlying order and the twists and turns allows and produces the type of creature that can know God and then eventually can be redeemed by God through salvation history. And so I will stop there and open up for plenty of time for questions.
No? Oh, there we go. Thank you, Dr. Kuebler. I especially appreciated hearing about how like the chanciness, as you called it, death and destruction don't contradict order and life, but rather complement each other, and how that relationship parallels salvation history because of God's presence in both of those processes. So thank you.
So at this point in time, we're going to open it up for questions. You can go ahead and start forming a line on either side once you have a question in mind. Thank you.
Take advantage of my position. Sorry, Richard. So, this is a huge topic, so feel free to reject the question if you want to. But how do you put together specifically the evolution of man with the Catholic understanding of original sin, in the sense of God placing so much responsibility in the first men and women? And if like from an evolutionary perspective, it would be like very primitive kind of human beings. I don't know. If you can enlighten that aspect in any way, that would be very cool.
Yeah, that's a whole nother lecture there. One that I'm not an expert in dealing with. But I think there's there's different ways that I've seen that people have looked at that. So the idea of first humans and the fall and so forth, right? And so like Saint Irenaeus talks about the first humans they fell, but it was more like children in the sense that they didn't really know any better, right? And it was sort of his view of it, where like Augustine doesn't think so. It's just they were fully formed, they were fully culpable. So humans emerging from the evolutionary process. So at a certain point, there has to be in hominid evolution, the species that are more closely related to humans than modern chimps. you reach a point where you have the type of creature that is, from a Catholic perspective, is fitting to be instilled with a rational soul, right? And so it is a both and, that the evolutionary process can only, from the Catholic, can only bring you so far, right? And that there's a point where there's the gift of this is the type of thing that is infused with a rational soul, right? That can be in relationship with God as the intellect and will. And then it's the Catholic belief that also, not only that, but that for humans, it's these preternatural gifts, that they were in relation to God in a way that we aren't, right? And so what that looks like and how that, who knows, right? It's hard to get into the mindset of, okay, how might that have happened? It's one of those questions of, like, if I had the preternatural gifts, what would that look like? I don't know, why would you ever sin? But at any rate, it's not, it's not clear exactly how that fits out. And I think just evolutionarily, we'll never really know, right? It's very difficult to know when do you have, the first biologically modern human. Right? There's a debate because of the nature of the fossil record, the difficulties of distinguishing, and then the lag in cultural artifacts that don't show up till well after you start to see anatomically modern humans. Right? So where do you have that divide that we're the first sort of humans made in relation with God, right? And it's an interesting question, but there's no obvious, There's ways you can make that fit, but it's one of those questions we'll probably never be able to fully address.
This one kind of builds on that one. What is, so you got the whole Catholic view of evolution. What's the Catholic view on, explain but also correct, like genetically modified organisms and then genetically modified humans? If I wanted to, have my son's genes fly so he has claws and climb walls or something, is that wrong?
Well, I mean, from a Catholic perspective, genetically modifying humans, at least currently, is only something where you're modifying human embryos, and so it's going to be embryo destructive research. So from a Catholic perspective, that's going to be problematic just from there. And then the question of enhancement versus genetically correcting disease, that's another distinction that the church would make. Right? Then when it comes to genetically modifying organisms, that again, it's a prudential question. It's like, okay, what are you doing? What's the risk? What's the benefit? So it's not like, oh, you can't do that. From a Catholic perspective, it's much more nuanced. It would have to be, okay, what's the example? It's not like you can't do that.
Hi. Excuse me. So, just recently I've taken in sort of a new interest in human consciousness, like self-awareness. I'm curious if I know it's a heavily debated topic in science and whatnot, but I'm curious if there's any sort of theory that you resonate with, and how that ties into evolution and how it came to be, and religion and all of those factors.
Like how human consciousness comes to
yeah, where in the timeline, and why or how. If you can elaborate on that.
Right. From Catholic perspective and my perspective, our intellectual ability is something that goes beyond just the material. There's things that we could do that transcend sort of our material. It's dependent upon the material, but it transcends that. Even consciousness itself, I think there's good arguments that it goes beyond, even though it's a material thing, it goes beyond that. So even animal consciousness, there's something about that. And there's even, sort of agnostic or atheist philosophers like Thomas Nagel, for example, who argue that there's mind, that matter on its own doesn't necessarily give rise to mind, that there's mind stuff in the universe in addition to matter, because it's a difficult question to try to understand how the two are related, right? But the more important question is the human intellect, our ability to grasp universals and so forth seems to imply that there's something that is immaterial about the human intellect, right? And so that's, the church argues that the human soul is what is transforms, say a conscious hominid into something that has an intellect and will. And it's not that like the other hominids didn't have reason, right? They have reasoning ability, but not at the level, right? The intellect that humans have. And that's, and I think there's good arguments philosophically for that.
Yeah, thank you.
One of the fallacies that we talk about is the fallacy of believing in like the great chain of being or the ladder of nature. The idea that there is like a hierarchy of beings, but how do we reconcile the belief in human dignity above animals and plants within that fact that there is no like prime creature that's been evolved?
So the idea, like this ladder, that there's a fallacy that there's like.
Yeah, they've taught it in a couple classes that I've taken, in which they say that they titled the fallacy "The Ladder of Nature," and they say that you can't have, there's no like prime ultimate creature that's been evolved. So
Right.
it's like the argument that like a worm is no less.
Yeah. So from like when you talk about like the dignity of the human person, right? It's like there's some inherent worth and dignity of the human person over a worm, right? Okay. That is not a scientific question, right? So in science, you can't say, oh, just scientifically say, well, a human has more dignity than a worm. It's like you can't measure dignity. But you could scientifically say, well, a human has more complexity and behavior and is more, it depends how you define complexity scientifically. You could argue that it is a more advanced creature if you define the term advanced scientifically, right? So I think it's a fallacy to say that you can't say that there's inherent, that there is more dignity in one creature than another. Because you can make philosophical arguments that humans have dignity that is at work that is more than a cat or more than a worm, right? But that dignity is not going to be fully reduced to biology. It should. I think it maps with biology in a sense that there's more complex behaviors, abilities that humans have, right? And then you step back and say, okay, well, philosophically, what does that mean, right? And that's where dignity comes in, and sort of this argument that humans are, from a Catholic point, the crown of creation, right? And it's not in the sense that, we get to dominate everything, but now you have a responsibility, right, as the crown of creation, right? So.
Thank you.
Hi. I was wondering if, as a Catholic, you can believe in luck.
No, because I never have it. So. I think, like, from a human perspective, like, chance events occur. Like, as far as I'm concerned, if I take a dice and roll it here, it's luck and it's chance. But from God's perspective, and it's impossible for us to get into God's perspective because we're stuck in time. So from God's perspective, there is no such thing as sort of luck. He knows what I'm going to roll, but like from all eternity, he knows everything that's going to happen. But certainly from our perspective, there is things that are luck and chance. And God can use those, right, to teach you humility, right, when you don't have luck.
My question is about the direction of evolution. I always heard that in the beginning, the first theories they would explain this change in species adaptation because of survival. That's the main drive. You want to survive, adapt to the environment. But it seems to me that this upward scale toward more complex things is also more unstable. More unstable as a mammal, as a human, and as a bacteria, a virus, right? So why would nature evolve in a direction of less stability if it wants to survive? That's the question. So you might think, as theologian said, that there could be, you could explain this as a hovering spirit, kind of directing things, but biologists who don't have that perspective, biologists who look at the evidence and data, how do they explain this perfection of developing more unstable and complex and difficult to come about forms of life?
Right.
How is there any biological or evidence that how do they explain that?
Yeah, I think that like just from a scientific perspective, how do you explain why do you get more complexity sort of evolving over time, right? You know, part of it is that Stephen Jay Gould in one of his books talks about this as a deceased paleontologist, but talks about like when we start at with very simple things, there's really only one way to go. There's just random fluctuations. You're going to move in the direction of more complexity. But also that to get to like you know, multicellular organisms, you have to have a certain amount of complexity in single cells. So there's this, once certain things evolve, that opens up opportunities for other things, right? So once you have large, you know, plants on land, that opens up an opportunity for animals to eat those things, right? If you don't have those there, you're not going to have, like, land-dwelling tetrapods are not going to have the nutrients to be able to survive. So it's as you lay the foundation that allows certain opportunities to then exist. And those opportunities, the more complex opportunities, require those simpler forms, right? And so those simpler forms provide that possibility over time. And those simpler forms store that information and share that information in their genome through lateral transfer sometimes to help increase complexity and so forth. So there is this stability that you need to have at the lower level to allow for these more complex organisms. And they're dependent upon those lower organisms. Why you still have simple bacteria for 3.5 billion years after the first cyanobacteria probably came into, because they set that basic level to move forward.
I found the Big Bang Theory timeline really interesting, and I was wondering, like, from a Catholic perspective, where Adam and Eve would be in that timeline.
Yeah, so like as the question of first humans, right? And so like the Catechism talks about, you know, the Adam and Eve and the fall, and how that describes, you know, in figurative language to describe a historical event, that there is there's first humans at some point, right? And like when exactly that occurred, you know, we don't know. I would say based in like, so it's a pin me down an answer, I would say that was probably, you know, the first humans would have been about 200,000 years ago, right? Based upon anatomically modern humans, and when you see those, and when you start to see cultural complexity, you see sort of artifacts that you say, well, whoever made that artifact was just like you and me, right? So, and those really start to take off around 100,000 years ago, and really take off about 50,000 years ago. So I think it's got to be before that, right? And then anatomically, it seems somewhere around 200,000 years ago.
I was curious about where the other hominid ancestors like fit in, because like Neanderthals, they had cave paintings, they had like burials, they had like a culture and consciousness. Just how do they fit in with like the standard Catholic? Yeah,
no, that's a great question. So there is evidence that Neanderthals' beards are dead. I think that evidence is equivocal, but there's pretty good evidence that they did the cave paintings. There's one, I think it dates to about 10,000 to 15,000 years before modern humans got into Europe, and there's some cave paintings when Neanderthals were there. What to make of those? You know, we do know that modern humans interbred with Neanderthals, right? And so were they humans theologically just like we are? Are they made in the image like, did they have, you know, is it, so it's possible some later Neanderthals, because if you look at Neanderthals have been around for at least 500,000, were around for about 500,000 years. But if you look at Neanderthal skulls for 400,000 years, they can be distinguished from more recent Neanderthals. So, you know, is more recent Neanderthals have more, are they humans just like you and I? You know, it's not clear, but they clearly humans interacted and interbred with them. Theologically, what to do with them, I don't know. Yeah. But I think if they did have the ability to do paintings and conceptual thought, then they're human just like you and I in that sense. Yeah.
I think it is beautiful that Catholicism agrees with evolution, supports science, including the popes, including John Paul II, who had scientist meetings of various scientists at Castel Gandolfo. Several years ago, we had a debate here between the evolution versus intelligent design, and it was very disturbing that intelligent design was so prevalent, and just the creation as in Old Testament. What is the situation now? Are other Christian groups more accepting evolution? Is there a hope?
Yeah, a few years ago I did like a 2-month seminar with a bunch of faculty from a lot of different Christian schools across the country, and the thing I came away with was that there was no consensus amongst Christian schools. But I think the majority of them, because they were biologists and they teach, that teach evolution at their schools, and I think the majority of them said that they didn't find much pushback from their students, and it really depends on the denomination. And there was a significant minority that said that they did get a lot of pushback from their students still. But if I had the number of guess of the people, there was like 50 of us, and I'd say maybe 10, so like 20% of them fell into that category.
Thank you. We have time for 2 more questions.
Perfect. This might be an awkward follow-up based on the last question, but I'm actually more Protestant Christian and was invited to this event, so I apologize if some of this is stuff that maybe in Catholicism they already teach, but I think for me, just looking at the creation story, a lot of it kind of maybe having more figurative context isn't something that I've wrestled with, but I think the most is just kind of the genealogy of Jesus and how to kind of reconcile that. And so I guess kind of in the Catholic take of the first humans, is that then genealogically connecting to Jesus and literally kind of that timeline that we see that seems to be talked about in the Bible? Is that different? And then I kind of also am wondering, is it completely unreasonable from your perspective as a biologist to kind of still wrestle with the idea of evolution when you're trying to compare it to the Word of God, in the sense of there's something we're missing as scientists still that it explains kind of those time discrepancies that we see? Or from the Catholic view, is it just completely figurative, like Genesis chapter 1 and Genesis chapter 2?
Yeah, that's it's good. The genealogies where it's there's 50 generations or what like 100 generations from Moses to David, and is that what you're referring to?
It all traces back to Adam, essentially, when you go through the genealogy.
Yes.
At some point. So yeah.
Right, and so if from a Catholic perspective, at least from my perspective, and is that. That genealogy, the first 10 chapters, 11 chapters of Genesis, exactly what to make of those. They are history in some sense, but they're not history in the sense that any moderns would call history, right? And so exactly what the meaning of the author is, right? It's kind of like the Adam and Eve story of the fall. It's a figurative description of a real event, right? So it's history once, but it's not historical in the way us or even the Greeks would have thought of history, right? And so the church is very cautious in its interpretations of making a definitive interpretation about that, and allows for a range of views on what, how you have to take those passages and so forth. So it's very, there is no definitive, there must have been that many generations, and that's church teaching, and it could not have been, some figurative meaning there, the numerology there being.
1,500 years from Jesus to Adam is what it comes out to.
Okay, yeah, right.
And then the second part of my question, and kind of what she alluded to, where she's like, is there hope? I mean, I wonder how, as a Christian who's trying to really understand the Bible where it's literal and not, Like, do you see any wiggle room in the science side where our understanding of evolution, do you think it ever be reconciled with the biblical timeline, or do you think the biblical timeline would never be reconciled based on the science from what you've experienced?
Yeah, I think based on the science, the thing that I think it's going to be most difficult to reconcile with the biblical timeline is the idea is that you have these, the artifacts that are, to me, clear evidence of rational conceptual thought that are 50,000 years old, right? And so that to me is like, I don't see how you could ever fix that to the biblical timeline other than saying, oh, there was rational creatures before Adam, which doesn't, from a Catholic perspective, is not something, that would fit, right? And so there is a book, if you're interested in this, there's a book, he's a Protestant, Swamidas is his last name. It's like the genealogy of Adam and Eve. So it's kind of, he makes this argument, he makes the distinction between genetic and genealogical ancestors, right? And it doesn't work in a Catholic context, but it might work in a Protestant context, where he argues that Adam and Eve lived 6,000 years ago or whatever, and that's enough time that, but they weren't the only humans that existed in that, but all modern humans at least have them somewhere on their family tree, right? Genealogically, even though they aren't genetically, that's possible, right? That is possible, but that from a Catholic perspective doesn't make any sense, because there's 6,000 years ago, there's a whole bunch of humans that live, and he says, well, then Adam and Eve, and so it doesn't, but it's an interesting sort of take on that, and I don't know the sort of how Protestants fall on that. I think it's Swamidas is his last name.
Well, thank you very much. Yeah.
How does theology address the problem of chance events negatively affecting otherwise seemingly innocent individuals, like the death of a child due to sickness?
That's why I'm not a theologian, so that's the theodicy question, there's like, why do you have sort of natural evils, like floods and all these things? And the most I can say about this that I don't know, right? It's like, there clearly is like a creative aspect of chance mutations and so forth, and so without those, you don't have sort of this novelty that comes in evolution, and the flip side of that is it opens up the possibility for sort of genetic mutations that lead to disorders and disease, right? And from a Christian perspective, the only sort of answer is that Christ entered into that mess of the world and died and rose. But for someone that actually is dealing with that often isn't a very satisfying answer, right? So, but that's yeah.
Well, everyone, that's about all the time that we have for questions. Thank you again, Dr. Kuebler, for your contribution to the Newman Lecture Series and for your years of work contributing to the intellectual fields of science and faith. And so if you want to say any last minute words, now's the chance.
Well, thank you guys for coming. You have some wonderful questions, and I'll be around if anyone wants to call and ask a question in private that doesn't want to say out loud. I'll be happy to talk with anybody afterwards. So thanks. Really enjoyed your questions.
Thank you. Give a special thank you to all of our sponsors whose support makes these intellectual conversations, along with all that we do here at the Newman Center, possible. And